For Engineering, Mathematics and Modeling Week 7, I would like to take a short look at first order linear differential equations with constant coefficients as a bit of a precursor to this. We have that a first order linear differential equation can be written out as a times dy dt, dy dx, plus b times y is equal to some function g of x, and if g of x is equal to 0, we call it homogeneous, and if it is not equal to 0, it is inhomogeneous. And for now we will be looking at homogeneous equations. In week 8 we will look at this case also for second order differential equations. So what are we really looking at? And I'll write out dy dx as y prime. For our case we're looking at a y prime plus by is equal to 0. This is one, well actually, write it shorthand, I will keep that notation. A dy dt plus by is equal to 0. Now I want to solve this using separate variables. The first step is writing it as a dy dt is equal to minus b times y. Separation of variables where I have minus 1 over y dy is minus b over a dt. The next step is integrating left and right. 1 over y dy is equal to integral of minus b over a dt. I can write out the solution for this. This is the natural, I'll continue here, ln y absolute is equal to minus b over, oh sorry, I'm writing t here when I should be writing x. So it's minus b over a times x. So first we separate them out, we integrate here to y, there to x, and we get this. Now I don't want the ln here, I want y absolute, so I take e to the power of ln y absolute is equal to e to the power of this whole right hand side. And then I have y absolute is e to the power of minus b over a x times e to the power of c. And we already saw in previous weeks that then we have our solution y of x is some kind of constant times e to the power of minus b over a x. And we will write this in the form c1 e to the power of lambda x, with in this case lambda is minus b over a. And the take-home message of this part is that if we have a first order linear differential equation with constant coefficients, our solutions have this shape. Some constant times e to the power of lambda x. And this will be the starting point of, for second order linear differential equations with constant coefficients. Find the whole set of equations, whole set of that case. But if we look at first order differential equations, then we find this shape of solution.